Welcome back, everyone, to the Luxman D105u. Hopefully you saw the previous video where we managed to resurrect this thing from the brink, fix my boo-boos, just get the machine to a working state, and now we're going to attempt the calibration process on this. I'm not looking forward to this, but it's going to be one hell of a learning experience. To be clear, I'm not an expert on CD players. I'm not an expert on anything, but I am good at thinking on my feet, and I love to learn by working on things. And maybe I can offer some guidance on this by just documenting this whole process on what I learnt trying to do this calibration one step at a time. So first things first, we're going to pull out the CD transport again, and we're just going to give it a bit of a re-grease and just make sure everything is looking okay for the calibration process. So let's just rip that out first, and I'll just show you what I'm going to do. Now, overall, there's not much I need to do here. This is just a quick sort of sanity check to make sure there's nothing wrong that we're trying to calibrate out of the unit. I just want to clean the lens, re-lubricate these rails, which are pretty dry at the moment, redo the grease on these plastic gears, and yeah, we'll be pretty much good to go. I'll be using Plus Guard for the plastics, just because I have it. I wouldn't be too worried about that. And a Molykote 33 medium for the rails, because I like how this stuff sticks to metal and has a nice film. So yeah, we're just going to get this done quickly and move on to the calibration. All right, so I got the unit re-greased, pretty happy with it overall. I also just greased the gear underneath the tray as well off camera. Nothing really to do there. New grease on the drive gear. Pretty happy with that. So I'm going to throw this back in and let's calibrate. Okay, so the calibration process. I've gone through the service manual and trying to wrap my head around what we actually need to do here. The first thing that is mentioned is that we need a test CD. There are two mentioned here, and it mentions using the second track. So I went hunting online. I found a download for the Sony YEDS 18 CD, which is what I've done. I'm sure there's probably some CD techs that are screaming right now saying you can't use a burnt copy of it. Well, I'm going to, because that's all I have to work with. So you got to use what you've got. All right. So I've burnt the disc. It's in there currently, and it is 22 tracks. And we want the second track, and the second track specifically is a 1 kilohertz sine wave at a 0 dB reference level. So technically you probably don't need this specific CD, you just need a track with a 1 kilohertz 0 dB test signal. The first adjustment is the VCO, and it says that we need to find test point 1, measure the voltage, find test point 2, and we need to adjust VR202, so test point 2 is half of test point 1. Cool, we can do that. That's pretty straightforward, right? Wrong. No test points anywhere. So I've been perusing the schematic, trying to figure out what the hell we've got to do here. I hope this flickering is really bad with white. I'm sorry, but this is all I've got. So I found test point 1 on the schematic, and it is related to this chip, which is this chip here. I don't want to measure off that because the pins are really close together and I'm going to short something out. So we're not doing that. There were 2 test points here and here that we could have used. So I decided to follow this across over and over and over. And I found it also goes to this chip on, so we've got 1, 2, 3, 4, 5, pin 5, which is this chip here. And I have marked it with a little scribe where we're looking. And it just so happens test point 2 is 1, 2, 3, 4. Hang on. 1, 2, 3, 4, 5, 6, 7, 8, 9 pins across. And I have marked that one also. So that is test point 2. So we want the voltage from this pin. We want to measure the voltage from this pin and adjust it so this pin is half of that. So I will show you quickly what it is at the moment. I have to be super careful here so I don't slip. So I've got 4.89 volts, and then we go to the other pin. And it looks like we're pretty much bang on, but I'm just going to double check that and we'll come back. All right. It was out by a tiny smidge, so I've adjusted it to 2.446 volts, which is exactly half of the value that we're using as the reference. So VCO is done. Now we're going to be moving on to the oscilloscope. Ooh. All right, so we're on to focus bias adjustment, step 2. This is test point 3 and the adjustment trim pot VR201. So again, we have to do some detective work and we are looking for test point 3, which does not exist on the PCB, but it is R277, which I managed to track down on the board. And it is this one just here. So we have to basically get an oscilloscope probe into there to measure our adjustment. It's just a great design. I love this. I had to do a lot of research on this. It was not easy to figure this out because I have a digital oscilloscope, and apparently this adjustment, you really sort of want an analog oscilloscope, but I've managed to work it out now, so I'm going to take you through what I found. All right, so caveat, I'll say it again, I am not an expert on this. I am just fumbling my way through this based on stuff I can find on the forums. And yeah, so focus bias adjustment, we are looking for this sort of an eye pattern on the oscilloscope, which has got and basically like diamond formations in here based on what I can find. Now, it's a thing with these digital oscilloscopes where they don't like to play ball with this because they don't have a phosphor screen, the persistence isn't very high, and they just refresh too fast to get anything meaningful out of this. So it's recommended to have an analog CRT oscilloscope for doing this sort of an adjustment. But I think I've got to the point now where I'm happy and I've figured it out. So I'll just show you what I've done. Okay. So under my acquire settings, I am using an acquisition on peak detection. I found that was the best option. Sampling rate is on equal time. Memory depth is on long-term memory. So that's what I found worked best for this. Under the display settings, type is on vectors, which is the default. But I also found that setting the persistence to infinite is a requirement. You can see here that there's nothing meaningful happening. If we turn on the persistence, now we're starting to draw on the screen and get that effect that we're looking for. So you need to have a digital oscilloscope that has persistence available. So just keep that in mind. We are on 220 millivolts. I'm using the fine tuning adjustment on my oscilloscope. Probe is on 1x. AC coupling. I also have the digital filter turned on with an upper limit of 2.5 megahertz just to clean up the signal a bit, and the bandwidth limit is on. Some of this stuff you don't need. I just found this helped clean up the image as much as possible, so I could see what was going on. Now, I tend to have the display open so I can clear the background and we can start redrawing what is going on here. The two things we are looking for is a clean diamond pattern, and we are also looking for the maximum amplitude on this signal. So if I start moving this trim pot, I've purposely knocked it out of whack now so you can see it move. And you can see at the moment, it's just sort of filling in the entire background. There are no real patterns emerging. There is a few little segments that look like diamonds, but they quickly get sort of buried in the noise. And also the amplitude, if you watch it, it's going to increase as I dial this up a little bit. And you can see we're almost at the edges of the screen now. So this is roughly where I found the best setting. So if I clear the screen again, now we can see these diamond patterns emerging, and they pretty much sit there for a long time, and it'll just keep drawing all over the screen, but those patterns will be pretty persistent, which is great. So that is what we are looking for. We are looking for the maximum amplitude we can get out of it. I've set up the screen so it's like right near the edges, but not completely over it. So we know we're in the ballpark at the moment, and these diamond patterns are holding. Now, the other thing I will mention is that this is a pressed CD. If I load in that written CD I did, the test CD, and I'll clear it again, you can see the amplitude has dropped. So the signal is weaker with the written CD. And you can also see those diamond patterns are not really present now. They are sort of there, but they're not as clear. I'm sure if I probably enlarged it, it will probably come back a bit. But long story short, I recommend that you use an original pressed CD, not a written CD, because you'll get more amplitude and it just seems to be a cleaner signal. And you don't, after doing all this research, you don't need a test CD per se. You don't need that 1 kilohertz test tone. You just need a signal coming through that it's currently reading. And you can see the amplitude has jumped right out, and now it's filling in the outer areas. And now we clear it, and we've got our diamond pattern back. So yeah, use an original press CD for doing this adjustment. So I'm going to finish this up, get it as clean as I can, and we'll come back. Okay, a little bit of messing around, tweaking it a little bit, and I'm really happy with it, to be honest. I'll clear it one more time and just show you. It's looking really good. We've got nice diamond patterns happening in here. Interesting side note though, and I don't know if this is like a thing or not, maybe some laser technicians who have worked on CD players can chime in on this, but you can actually listen to the laser pickup itself, and I could have almost achieved this just by listening to it, because it has like this coil whine or like a screeching high-pitched sound, electrical sort of sound that comes through the laser pickup, and as you adjust it, it'll sort of change pitch in one direction or in the other, and then there's sort of this middle ground where it just settles down, and it just sounds happier. And I would try doing it just by ear, and it was pretty much bang on. So that was an interesting little thing. I forgot to mention also the time base is on 200 nanoseconds, but I guess that might change depending on the player. If it's this machine, I guess it'll be about the same. And like I said, 220 millivolts. Yeah, happy with that. We're calling this adjustment done. And now we're moving on to the tracking error balance adjustment. And let's see if we can figure this one out. All right, so this adjustment is going to be a little tricky, but I'm going to try to explain it as best I can. It involves 3 test points, TP4, 5, and 6. We have to short circuit TP4 and TP5 together. So I go and put on my little detective hat again, and I'm looking where these test points actually are. So TP4 is up here, and there is a resistor on that side, but I decided to follow it down to this chip, and it goes to a pin called GFS. I'm like, okay, cool, I can find that on the chip. And then the other one, test point 5, goes to the 5-volt pin on the same chip. So I was going to use the chip to work this out, but I went hunting on the board, and I actually found there are 2 pin headers here to latch onto. And they are actually labeled, believe it or not. I was quite surprised at this. There's a 5-volt one here, and this one is labeled as GFS, which are the correct names for what we're looking for. They're not labeled as test points, but they are correct, just worded differently. So anyway, I've soldered a wire between these 2 posts, which is what is stated in the manual, and we're all good there. Now, test point 6 is not mentioned here at all. It just says adjust VR203, so voltage is blah, but it doesn't mention test point 4, 5, or 6, or which one you're supposed to use. So I translated the bottom area, and it mentions test point 6 in a weird way that is what we're using to find our reading. Now, test point 6 is way more obscure. It is actually just here with a little, I've marked it with a black dot where TE is. That's resistor 272 on that side we have to measure. So that's our test point for checking this voltage. We are setting this trim pot all the way counterclockwise for the adjustment, and this is the one that we're actually adjusting for this specific adjustment. So I'm going to set this up and let's get this done. All right, so I've tried to get you the best seat in the house that we can do. I've got the multimeter turned on its side so you can see what's happening. We're going to turn the first trim pot all the way back counterclockwise, and the CD player loses its mind when you do this and makes bad noises. It is normal from what I can tell, so don't freak out. We're going to do this, and then we're going to adjust that setting. Okay, so we're not too far out. So now we're going to turn this one up. I think that's good. We're going to turn this back up and see where we're sitting. Yep, all good. We're going to leave that. So plus or minus 50 millivolts was the target, and we're well within that range. So yeah, let's have a look at these other 2 adjustments and see if there's anything we can do in regards to those, because they're a little tricky. All right, so these last 2 adjustments are sort of a brick wall for me, unfortunately, but I did figure some things out which might help your average person who doesn't have a lot of tools available. Long story short, the original service manual calls for a jig, which we do not have, which I guess was like a service center tool for making these adjustments. I don't think you necessarily need this, but it is specified for this specific player. And I went and looked at some other service manuals for other CD players, and their adjustments are a lot more vague and by feel. So I decided to just go down that road, and it seems to have worked out pretty well. These adjustments are not like the end of the world adjustments. I found if they're both in the middle of their range, they worked fine, but they could be better. So Yeah. Okay, so what did I find? Well, we'll do the first one, the tracking gain adjustment. And what I found is if this isn't set correctly, it would be overly sensitive to tapping. And you can see at the moment, I'm tapping it pretty good and it's happy, right? So if I turn this one down, so we'll go down to say there. Now I start tapping on it, and I'm actually tapping lighter as well. And you can see how much it's jumping now. So that was enough for me to play around with this adjustment because it was generating real world results I could work with. So the factory position after those other adjustments is the center point. And I found that was pretty good. And I ended up going just like a little bit past it, and it's happy there. It sounds good. It does give you some feedback, like with how the CD sounds while it's playing. And that can help you get a feel for what you're actually working with. So, yeah, the final adjustment in this video is the focus gain adjustment. And this one was really interesting that I found. And basically, what I ended up doing, I was playing around with my oscilloscope trying to find something that I could work with, and I wasn't really getting anywhere. What I ended up doing was I grabbed this garbage CD that was stuck in the machine when I got it. I decided to cover it in fingerprints and just getting it really mucky so it was hard to read. And what I found was all those defects with grease and fingerprints and all that would really affect this focus gain adjustment. If it was too far in either direction, you would hear ticking or popping as the pickup is losing signal, I assume, with all the defects that are on the disc. And basically I found where it started having issues in each side, and then I put it in the dead center of the two of them, and basically it became dead quiet there. It went from having audible ticking and pops and all sorts of weird noises to just being nice and clean. And that pretty much told me all I needed to know about this adjustment. I was happy with it. If it can read a disc with crap all over the back of it, it's not going to have any issues with discs you look after. And I'm happy with that. And it just sounds better as well. It's nice and smooth. It's not making little squeaky noises and scrapey noises when it's really turned up. And yeah, so that is it. We couldn't do the proper adjustments for these, but I think honestly they're really good, and I can't fault this player. I've tried that disc with all the crap on it. I've tried CDRs. I tried a CDRW. I tried some press discs. I cannot fault this player anymore, and it has not skipped a beat once, which I'm really impressed with. So yeah, that is it. I've been using my headphones on the headphone output to listen to the discs, and these are like really, really sensitive. They'll pick up any sort of distortion and issues. So yeah, I'm done. This went very well. I hope these adjustments maybe help someone get these players back to life. I'm not sure how many people are even servicing these things anymore. And we'll be back with a final video on this where we'll look at the overall design of it, because it has some really weird things going on with it. But that's it for this video, and I hope you enjoyed it. I will see you in the next video.